So a coordinate system is what you use to be able to graph ratios onto a coordinate grid. So anytime that we're graphing, you're going to be dealing with a regular coordinate grid, and this is actually quadrant 1 of your coordinate grid. And this is going to be the grid that counts with positive numbers on the x-axis and positive numbers on the y-axis. So this axis down here is x. This one is y. X is always going to be horizontal, and y is always going to be vertical. Okay, this spot right here is called your point of origin. It means where does it originate from? It always starts at 0. So this point right here would be 0. And you also have 0 going vertically as well. Okay.
Ms. Lanford, I hate to interrupt, but would you send me and that student into a breakout room, please?
Yes, I can.
Thank you.
Sorry, for some reason it highlighted everybody's name. I'm trying to take everybody off. Bear with me for just a second, guys. Okay. So when we have a coordinate system just like this, excuse me, we have to be able to get things on there. So how we figure out where to put something, where to plot something, is we use what we call an ordered pair. Okay. Ordered pair. These are always given to you in an XY form. X is always first, Y is always second. X meaning this X axis or the horizontal movement, Y meaning the Y axis or the vertical movement. Okay. So to the side and then up. You have to run before you can jump. So an ordered pair might look something like that. So what this is telling us is that we would go 10 spaces out or horizontally, and then we would go 6 spaces up, and your dot would be where those 2 points meet. So where the point of 10 meets and where the point of 6 meets, where my fingers meet would be where that dot goes. Okay. All right, so this part should be pretty familiar. You've done this before. Now let's look at how we would get our ratios on there. So you could have ratio tables. There's kind of two standard ways that you're going to see them. You're going to see your vertical table just like this, or you're going to see a horizontal table just like this. Okay. On your vertical tables, typically X is always on the left-hand side and Y is always on the right-hand side, which is really great because it gives you your ordered pairs. So if I had 0, 0, that would tell me where my first dot would go. It would go in the point of origin. If my next ratio was 2 to 4, I would come out 2 and I would go up 4. My dot would be right there. It's an ordered pair, okay? So if I had 0, 0, 2, 4, 4, 8, 6, 12, what would my next ordered pair be? And you may unmute and tell me.
816.
8, 16, awesome. Okay. Anytime that you see a horizontal ratio table, you typically are going to have Y on top and X underneath. Okay. So if you look at this table like this, all we did was lay it on its side. So the letters stayed in the same order. Okay. Sometimes they might be switched, but they'll be labeled if they're switched. But the majority of the time, probably 95% of the time, it's Y on top, X on bottom. And so you could put the same ordered pairs in. Just like that. Now there is a special note I need to give you. So I'm going to put a star. And then I'm going to write the word time in all caps, just like that. And I'm going to underline it. Time is always the x-axis. So if you're doing a problem that has time in it, I guarantee you it's always going to be the x-axis. There's no other option. Okay, so it will always be graphed on this horizontal axis. It'll always be on the left-hand side of these vertical ratio tables, and it'll always be on the bottom on these horizontal ratio tables. Okay, so from these ratio tables, there's several things that we can do. The first information that we can collect is the ordered pair. The ordered pair, we gather like this. You just isolate one section. So this would be an ordered pair. Okay, it does give us an XY. So your ordered pair there would be 2, 4. You can also gather ordered pairs out of these tables. So our ordered pair here would be 6, 12. You always label X first and Y second. So not only are we getting ordered pairs from these two sets of ratio tables, they're also giving us our ratios. Okay, so if these were how many students there were and how many cookies were eaten, that means 2 students ate 4 cookies. That would be the ratio. So cookies would be 4. Students would be 2, just like that. Could somebody help me find the unit rate? The unit rate would be, what does one student eat?
No
One
más
student
tienes
eats 2
internet.
cookies.
One student eats 2 cookies. Okay. So these ratio tables will also allow you to gather enough information to be able to calculate the unit rate. Okay. So all we're doing is taking all the things that we've done already and we're kind of combining them into something new. Okay. So I want you to think back a while back, we were talking about multiplicative and we were talking about additive relationships. And if you remember, multiplicative means that each time you moved to a new spot in the ratio table, it was being multiplied. Additive meant that it, or multiplied or divided. Additive meant that it was being added or subtracted. So on this ratio table, what kind of relationship do we have?
Multiplicative.
Times 2.
Multiplicative, good. So I'm going to go ahead and write that out there. Multiplicative. Okay, someone is talking, but we cannot hear you. You sound like a robot.
Got McDonald internet.
How do you say, Miss Lamford? Multiplicative?
Multa, say multa.
Multiplicative.
Plicative.
Multiplicative. Multiplicative.
Multiplicative. There you go.
Multiplicative.
There you go. And the other one is additive.
Multiplicative.
Multiplicative. Yes, you got it. Okay. So I'm going to stop sharing my notes and I'm going to start sharing a screen so we can look at some examples of these, okay? And we can kind of walk through them. Okay, so in today's lesson, we are going to be working on finding ratio tables, finding ratios from tables and graphing those ratios. So the first one that we come to is going to talk about finding ratios from tables. If we have 2 boxes of candles that contain 24 candles, each box holds the same number. So what we can see here is that 2 boxes does hold 24 candles. So the first thing I always do whenever I come to a ratio table is I find what the unit rate is, just like we did just a second ago with the cookies per students. So if 2 boxes holds
12 for 1 box.
candles, yes, 12 in 1 box. Awesome. So the way that you do that is you take the numbers in the first column and you write the ratio of candles to boxes. So 24 over 2. And then you set it equivalent to 1. So that would be 12 to 1. Okay. We did lots of practice with that over the last few days. Then we're going to use the unit rate of 12 over 1 to complete the table. So that means every time we see a box, we want to multiply it by 12. So 3 boxes would be 36. What would 4 boxes be?
48.
48.
48. What about if I have 60 candles? How many boxes is that?
5.
5.
Yeah.
5.
You could take 60 and divide it by 12, and then 7 would obviously be 84. What are the equivalent? So what you would do is you would then take all the equivalent ratios and you'd write them down. So we have 24, 2, 36, 3, 48, 4, 65, and 84, 7. Okay. That's how you find ratios in tables and how you put ratios into tables. Okay. Now, sometimes we ask you to graph these ratios. The table below shows the distance that Myrtle Express train travels at various times. It travels at a constant speed. What does constant speed mean? What does that tell us? Sarah?
That no matter what, they'll always go the same speed.
Exactly. So it means that no matter what, it will always be traveling at the exact same speed. So in 2 hours, where does time go on our grids?
100.
The x-axis.
X-axis, excellent. So in 2 hours, it goes 100 miles. So the first thing we want to do is find the unit rate. So what does it do in 1 hour?
50, I think.
50. Excellent. So 3 times 50.
150.
The unit rate. 3 times 50 would be 150. 4 hours would be 200 minutes. And in order for you to find this one right here, hang on, let me get my,
The 3.5.
in order for you to find the 3.5 right here, you'd have to do a little bit of math. Lottie, what do you think we should do?
Since it's 3.5, you could add half of 50 from 3
Excellent. Why would you add half of 50?
because 3.5 and there's 5 and 5 and 50 is what you're adding each time.
So 50 is what you're adding each time for 1 hour. And she's saying that the 0.5 means that it's half an hour. So if she took half of that hour, that would take it from 50 to 25. You could also set this up as a cross multiply and divide. Okay, so if you didn't know what to do, some of you can still see my screen over if you look at my name where my face would normally be. You could have taken that unit rate that you got, that 50 over 1, and you could have plugged the 3.5 in like that. And when you cross multiply and divide, it would have given you x equals 175. Okay, so anytime you don't know how to do it, remember that you do know how to cross multiply and divide. So we would write the information as ordered pairs. So our first one would be 2 coming first because it is on the x-axis right here. Okay, and then 100. So we'd go over to 2, we'd go over to 100. Right there is where I'd put a dot. My next one would be 3 and 150. So where is 3? I only see 2 and 4. Where would 3 be?
In the middle of 2 and 4.
In the middle. Please stop. And I would go up to 150, which would be right there. Okay. So there's my dots. And then at the end, you would start down here at the point of origin, which is at 0, 0, and you would draw a straight line that goes from the point of origin through all the dots, just like that. Okay. So let's try, hang on, this one. So I do not have much information at the beginning of this chart, but I do have a complete ratio right here. So this is saying for every 4 gallons of gas, it costs me $10. Now, can I go from 10 to 5?
Yes.
Yes, I can. It's half, right? So that means I can go from 4 to right here. What's half of 4?
2.
2, okay? So that means I could come in here and I could put, hang on, my pen disappeared. I could put a 2 just like that. Now let's look. Can I go from 2 to 6?
Yes. Yes.
What I do?
Yes.
Multiply by 3.
Times 3. So what's 5 times 3?
15.
15. Okay. Now let's look here. 5. What's half of 5? Well, that would be 2.5, right?
Yeah.
What's half of 2?
1.
1. Would 2.5 and 5 give me 7.5?
Yes.
So what is 1 and 2 combined?
3.
3.
There you go. We just filled out that ratio table. And let me clear off all the writing that I did. So it looks all nice and neat now. Okay.
That one was kind of confusing.
That one was kind of confusing. Okay, that one, Brandon, whenever you do that one, if you don't see the relationships with the numbers, being able to do it mentally like that, you can cross multiply and divide. So you could have taken this 4/10 right here, this 4/10. Hang on. You could have taken this one right here and you could have set it equal to 6 over blank, and you could have cross multiplied and divided. So it could have been 10 times 6 is 60. 60 divided by 4 would have given you 15. Does that make sense?
Yes.
Okay. So there's your dots and there is your relationship. Okay. So what Ella, and I love it, she was doing her betweens. Okay. So what you're going to get today for some practice, do not let this overwhelm you at all. Okay. I promise it's not as hard as everybody wants to make it in the beginning, just like yesterday's activity. Hang on, my computer screen doesn't want to. Doesn't want to cooperate. So that I can show you. Okay. Now can y'all see Canvas?
No, we can't.
Okay,
No.
let me stop sharing and reshare again. Now can you?
Yes.
We can.
Okay. So what you're going to get on Canvas today is the introduction to ratio tables and graphs. There is a reminder for your 20 minutes of Freckle. And then there's the daily warm up. Today you get to decide which of those pizzas was a better deal, the Pizza Hut or the Papa John's from the last 2 days, okay? I will be posting the notes so that if you didn't get them, you can catch up on them. And then there is a video down here posted. It's another teacher going through very similar examples, just like I did. You can view that if you need to, if I'm not available to you, but I will be available today. I'll stick around. Okay. So today's assignment is going to look like this. So don't start panicking right now if you don't completely understand. We are going to spend several days on this concept, okay? The first slide, all you're going to be doing is reading the information and completing the ratio table. Your second one is going to be completing a ratio table, just filling in the blanks. Another one where you complete the ratio table. And then right here, you'll answer who has the best lap time, Steve or Maria. Okay. Then you get to practice a little bit of graphing. You'll read all the information on here, fill in the ratio table, and then these dots can be drug into the graph so that you can make your own, you can plot your own spots. Okay. This one is going to be very similar. The only thing you're going to do now is you're going to use the arrow to draw, to be able to go through the point of origin through your spots. We're just practicing getting the numbers, getting them on a graph. We're not doing anything else with them right now. And then here, you're going to fill in the ratio table, and then it wants you to gather some information. How many inches did the creek rise in 8 hours? Well, once you fill in the ratio table, you'll be able to find that right here. What I want to show you, though, is something that a lot of people don't realize. If you've got numbers plotted on your graph, It's already giving you some information. So this one right here, it tells us in 1 hour, it increases in a 3-inch height. Well, if I come over here to 1, it's at 3. So what does it say for 2? 2 increases how much?
6 times.
Okay, so see how your dots tell you these answers. The ratio table gives you the spot for the dots. The dots help you fill in the ratio table. They work simultaneously. And then you're going to answer this question down here. Now, on this slide right here and this one right here, if you don't answer these boxes, then they are counted wrong. Okay.